So the day you had the quiz, you kind of read through those notes, and it talked about the polynomials have the same number of solutions as the highest degree. So if you have like an x to the 8th, you have 8 solutions. If you have x squared as your highest degree, you have 2 solutions. X to the 4th, you have 4. So polynomials with degree n have n solutions. Now, they're not all real solutions. They can be a combination of real and imaginary or complex. Right? Complex is just a combination of imaginary with real. All right, now, finding possible rational roots. This is probably not something you're ever going to have to do, honestly. This is something I would have had to do back in the day because we didn't have graphing calculators and we had to do this kind of a method. But this lets you know like what the possibilities are. So how to find possible roots. Because we're going to look at a calculator and we're going to say, oh look, here's our roots. But possible roots. You take the factors of the constant and you divide by factors of the leading coefficient, right? So here's my constant and here's my leading coefficient. Here's my constant, here's my leading coefficient. So these are the factors of 12. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Those are the factors of 12. These are the factors of 2. Then I divide. When you divide, you do each one separately. So I'm going to go divide by 1 first. Well, anytime you divide by 1, it doesn't change anything. So you have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Then you're going to divide by 2. Well, 1 divided by 2 is 1/2. 2 divided by 2 is 1, and I already have 1, so I don't need to write it again. 3 divided by 2 is 3/2. 4 divided by 2 is 2. I don't need to write it again. 6 divided by 2, I don't need to write it again. 12 divided by 2, I don't need to write it again. So these are all my possible solutions. Now, there's 1, 2, 3, 4, 5, 6, 7, 8, and each one has a positive and a negative. So there's 16 possible solutions. My highest degree is 4. So at the most, I'm going to have 4 solutions, and that might be a combination of imaginary and real, and these are not imaginary. So realize these are possibilities. These are not your answers. They are. I have way more possibilities than I have answers. So let's try the next one. So again, this is my constant. So I'm going to factor that. So I can do 1 is a factor, 2 is a factor, 3 is not a factor, 4 is a factor, 5 is a factor, 6 is not a factor, 7 is not a factor, 8 is not a factor, 9 is not a factor, 10 is a factor, and 20 is a factor. Those are all my factors of 20. My factors of 3 are plus or minus 1 and plus or minus 3. So again, I'm going to divide first by the 1. So I'm just going to write everything over again because everything divided by 1 is just itself. And then I'm going to divide by 3. So 1 divided by 3, 2 divided by 3 is 2/3. 4 divided by 3 is 4/3. 5 divided by 3 is 5/3. 10 divided by 3 is 10/3. And 20 divided by 3 is 20/3. And they all have a plus or minus in front of them. So on this one I have 5, 6, 7, 8, 9, 10, 11, 12. I have 24 possibilities. But I know in the end I'm only going to have 4 answers. But these are possibilities. Any questions on how to find the possibilities? And these are only the possible rational roots. They're not all the possibilities. Again, they don't include imaginary. Rational means I can turn it into a fraction. So they don't include irrational numbers, and they don't include imaginary. All right, so how do we test them? Well, we use synthetic division. And we look for remainders of 0. If the remainder is 0, then we know that that number is a root, or a 0. So that's what we're looking for. So let's say on this problem, x equals 2 was one of the possibilities, and I want to know, is that actually a 0? Well, we are going to divide by 2 and find out. So again, we check and make sure we have everything. We have x to the 3rd, x squared, x, and a constant, so we don't need to add any zeros. So we write in our constants. Bring down the first, I'm writing our coefficient, sorry. Bring down our first coefficient. Multiply 1 times 2, add negative 2 and 2. Multiply 0 times 2, add negative 9 and 0. Multiply negative 9 times 2, add 18 and negative 18, and I get 0. So yes, x equals 2 is a solution. And I know it's a solution because I got 0 as a remainder. So now, I could keep going. I could put this in my calculator. I could either look at possibilities and do this, or I could put it in my calculator and I could find some other, see if I have any other integer answers. But this is pretty easy in the term I have right now. So x cubed means I drop this to x squared. That's x. I don't need to write 0x, and that's my constant. I could either solve this by the square root method, or I could factor it. It's very quick and easy to factor if you remember what kind of factoring is this. It's a special kind. I have a perfect square and a perfect square and a minus. Difference of squares. This is x plus 3, x minus 3. So in terms of my factored form, well, there's two factors right there. X plus 3, x minus 3, and my other factor comes from this. Don't forget to go back and find your other factor. How do I change this to a factor? I change the sign, but I also have to add an x and change the sign. So add an x and change the sign. So there's my factored form. These two factors came from here. This last factor came from add an x and switch the sign. So now to find my zeros, I already have 1 0. Zeros, I'm going to write that down first so I don't forget. That's a 0. We said, is x equals 2 a solution? Yes, it is. So that's a 0. My other ones are going to come from these factors. X plus 3 equals 0, x minus 3 equals 0. So I get x equals negative 3 and x equals 3. So my zeros are 2, negative 3, and 3. My highest degree was 3, so I should have 3 solutions. And this one, they're all real. I have 3 real solutions for this problem.